And this is a very, very important incident to me because it left such an impression on my mind that I carry this experience now through all my projects. And what's neat sometimes, not necessarily the fact that this incident happened, but when you have an incident that happens of such significance, it's very easy in the future to convince people on the floor that they should do things properly just by relaying this incident to them. This is one of those types of incidents. This incident occurred when we were testing or preparing to environmentally test the Genesis payload canister. The Genesis mission was a mission to the sun to collect solar samples, bring them back to Earth. This was a return mission. And the payload was actually designed and built by JPL. The project was managed by JPL, and the flight system was built by Lockheed Martin. So part of the whole process, the outlow process, is environmental testing to make sure that you're simulating the actual flight environments on your hardware. So this particular test was going to be a thermal vacuum test of the actual flight payload, and it occurred when we were transferring the payload from its dolly or floor cart to the vacuum chamber. The process was to attach a particular piece of dedicated ground support equipment, which was a 3-leg lift fixture, to the overhead crane, attach it to the payload, and then pick the payload up off of its floor cart and move it over approximately, in this case was about 10 feet, to the thermal vacuum chamber where it was going to be mounted and then tested. Well, this was a particular lift that we had done numerous times, using that same piece of hardware numerous times, never having any problems at all. But this particular time, as we were picking up off of the payload support stand, we got about 8 to 10 inches off the stand when one of the 3 legs on the lift fixture basically separated from the payload. The payload swung away, and thankfully we had technicians in place, in close proximity, that were able to grab it and place it back on the actual dolly. So there was no damage to the hardware. However, there was some damage to the egos and the emotions of a lot of the people standing around. It was quite a shock, obviously, because multi-million-dollar piece of equipment that potentially could have been lost if it were at any other point in time in this process. But thankfully we got it back on the stand. The mitigating circumstances as to why this happened was in the lift train, or the dynamic load path, on this one leg of the sling, there was a swivel hoist ring that got attached to the structure that held another leg that lifted up the hardware. Well, that swivel hoist ring, we found out, was not fully engaged into the structure. It was, a matter of fact, only being held on by a couple of threads. So as we were lifting, those threads gave way, and consequently the failure happened. What we did to mitigate this in the future, obviously, was immediately we checked all of our lifting devices for that project to make sure that we had thread engagements. But also we made sure that as far as any process of lifting ground handling, even across the board, that all of these devices were checked prior to conducting a lift or prior to conducting a movement of any hardware. We made sure that we had eyes-on visual inspections of all these devices, especially in the dynamic load path, to make sure we had proper thread engagements, to make sure nothing was out of place. And that process was carried over into an overall JPL process that requires now that in a checklist process that those things get checked prior to actually doing the lift. JPL normally proof checks each of these pieces of lifting equipment, and the requirements are that once you do a proof test on a piece of equipment, which generally takes it above what it's designed to, that's why we call it a proof test, that after that proof test you send it off lab to a non-destruct lab to do further analysis on the dynamic load path. Specifically, do radiographic inspection and die pin inspection, say on the shackles, on the hooks, and everything in that path. Well, what had happened is after it came back from the vendor, There was an assumption made that everything was status quo as far as the thread engagements, as far as how that piece of lifting device was configured. And the assumption was that it was good to go. And it was actually used on multiple lifts prior to this incident happening. So now the process that's changed is that whenever you send something out to a vendor, especially GSE like this, that it gets checked thoroughly by QA prior to being put in the ATLO stream or in the testing stream. And then also, once it's put into that stream, that you make sure prior to doing any lift that it gets checked again by multiple sets of eyes, so that when you do the lift you have assurance that everything's in place.